the quiz question basically said it was number 5 from the practice exam, practice exam number 4, and the quiz basically it said 800 total marbles in the bag, and the sample, what they get in the sample, 16 out of 40. In the sample, the person drew out a handful, 16 out of 40, 16 red out of 40 in the sample. All right, so I'm telling you, it's just like the fishing deal, right? Tag over total is equal to tag over total. So out of and so it's instead of capture and recapture, right? It's sample and the whole bag or whatever, right? Right? There's the sample we took, the little thing we got in our hands, the sample we took versus what's in the whole bag. So in the sample we got, 16 out of 40, and that's, and the tag is like the red, right? The tag is like the red, it's the mark. So red out of total equals red out of total. So 16 red out of 40 total in the sample is X red out of 800 total in the whole bag. Solve for X. Does that make sense? Out of that, just like the fishing problem, right? 16 out of 40 equals X out of 800. Right? 16/40ths, because in other words, what the kid is going to think is that, well, in my little sample, 16/40ths of my little sample was red. Therefore, I assume that 16/40ths of the whole bag is probably red. Right? Yes, if you want to just think that way logically, you could just think, look, 16/40ths of the whole 80 is probably red. 800, not 80, 800, right? 16/40ths of the whole 800, right? Because 16/40ths of my little sample was red. So that seems reasonable to assume that that same portion of the whole bag would be red, right? Why would I get more red or less red in my sample? On average, anyway, right? I probably am getting a reasonable, that's the whole idea with polling. They ask a small group, they hope that's representative of the whole country. So same thing, right? They just grabbed a handful out of the bag, 16/40ths were red, so 16/40ths of the whole bag of 800 are probably red. What does of always do in math? Times. So that'd be times 800. You could do it that way, or, and that would be 320. Or you could just solve this little equation here that I'm showing you over here. Either way, I don't know, whoops. I don't know which way is easier for you. So I showed that way, and now I'm just going to show you the tag over total tag. Then you cross multiply. Remember how to solve the little two fractions that are equal? There's two different ways. You could just do it the first way or the second way. So what are you going to get? 16 times 800 equals 40 times x. Does that make sense? Remember the cross multiply thing? Right? Tag over total is tag total. Red over total is red over total. For the sample, for the whole bag. So to capture, recapture, it's sample and whole bag. Let's go diagonal, diagonal. Right? This is another way. And then what's that? So I'm being a 64. 12,800 is 40x. Yeah. Divide by 40, and you get the 320 answer that we saw a minute ago. So the kid's thinking there's probably about 320 red marbles in the bag. Based on my little sample, if that's true of the whole bag, there'd be 320 red marbles. Does that make sense? Like you could do that on the test tomorrow for the big points? Is that good? Questions on that one? It's a fishing problem. Tag over total, tag over total. A lot of it's, the trick is recognition, huh? You read all these words and you're like, how am I supposed to recognize that's the fishing thing? Right? Well, it's because you got the same proportion, right? The proportion in the sample. That's the whole idea of polling, isn't it? Right? When they ask a small group, how many of you are going to vote for this candidate, and it's 48%, then they think that's the same portion in the whole country, right? That's the very idea of sampling and polling, is with a little spoonful, you're trying to get the flavor of the whole, what's it called? Bucket? That's not the right word. What's this called on the stove? I'm losing my brain. pot. I guess pot. Yeah, pot. Pot of soup. Yeah, pot. That's the right word. Thanks. Yeah, right. I was thinking of what's his name saying, right? Gallup, George Gallup said, stir the soup well. One little spoonful tells you what the whole pot tastes like, right? That's the idea, right? So that's, I'm hoping, what will occur to you when you look at a question like that. You know, when you see this kind of a question, you'll right away think, oh, it's the portion thing. It's that same portion. All right, well, enough said. I've gone over that and over that. So we almost finished, right? That last section, we've got to finish that. I'm going to give you the practice exam, because today I really want to do a thorough job after you're done with the practice exam, going over it in detail. Because this is the one, this is the hardest one, followed by the easiest test. Basically, among the five, four's the hardest. What I mean is typically grades are lowest on the fourth, which always surprises me. I always think, it's just words. It's mostly words. But it's actually more tricky than the other exams. Not a lot, not dramatically, but a little bit lower than the other ones almost every semester, almost without exception. And then five's the highest by far. Not dramatically, but fair bit higher than the others. And all these problems are standard deviation, basically. That's the last concept I'm going to show you, and then give you the practice exam. And then we'll go over it. So you have like 45 minutes to it. Then we'll go over it. All right, so standard deviation. All right, I'm going to jump down to part B. How do you figure out standard deviation? Standard deviation. It's a special thing. What you're going to do is you're going to make one column for the numbers. All right, I'm going to do part B. Part A has 0 standard deviation. I'll get back to explaining why in a minute, but let's just go on to part B. Part B, we have 0, 6, 6, 12. 0, 6, 6, 12. So those are 4 numbers. Well, let me start to explain what standard. Standard deviation is average deviation. What does that mean? Deviation. What's a social deviant? What does that mean? It's deviant behavior. What does that mean? Not necessarily bad. Just different. It means different, right? Somebody could be kind of weirdly friendly, for example, in a strange way, right? That would be deviant behavior. It's different. It just means different. A social deviant is one whose social way of acting is different. So it just means different. Deviation means difference. So when we say, what's the standard? Standards like typical, normal, average, deviation among these numbers. What we mean is, how different are these numbers from one another on average? How spread are they? Standard deviation is a measure of spread. If you think about it, if there was a big data set, like if you guys said, how do we do as a class as a whole on the last exam? And I could tell you, I could read you all the numbers, and that'd be a terrible way. Remember what this chapter is all about. It's about how do you communicate a lot of numbers at once in a way that people can grab a hold of it. Well, you don't just read all the numbers. That's not how we work. You could show pictures, pie charts, histograms, all that stuff. Or you could tell an average, right? Mean, median. I can say the average on the last test was 75, or I don't know what it was. You know, I can tell you the average. And then you guys go, oh, okay, on average, 75. You know, half people did 75 and above, half did 75 and below. You kind of know how, you know something about the number set as a whole. But one thing you wouldn't know is how spread those numbers were. Maybe on the last exam, maybe the average, well, let's say it was 80. Let's say the average, well, 75. Let's say the average on the last exam was 75. I have no idea, I'm just making it up. There's 2 ways that could happen. Maybe there was a whole bunch of hundreds and 90s on the last exam and 89s. And then there was a whole bunch of 37s and 42s and 48s maybe. And the middle came out to be 75. Or maybe there was a whole bunch of 80s and 79s and 76s, 81, and there was some 74s and 73s and maybe a 72. And the average came out to be 75. See the difference in those 2 data sets? They both have the same middle, average 75. This data set does it by a whole bunch of super high numbers and a whole bunch of super low test scores. This class has the same middle, same average, and they're all close to that average, right? There's not much spread. So this group, the second group, would have a low SD. SD stands for standard deviation. This group would have a high SD, standard deviation. That's what it means. It's the spread, right? They can both have the same middle. But how's the spread? Are the numbers all packed in tight? Are they spread wide? So when the numbers are spread wide, like real high numbers, real low numbers, that's a high standard deviation. Over there, it's a low amount of standard average deviation. Okay, so that's the feel of it. That's what it generally is. Let me get that out of the way for our actual calculation here. So let's actually crank it out. So what I'll do is I'll show you by hand, and then I'm glad to show you by calculator. If you have your calculator with you, I can show you how to hit a few buttons, and whammo, you'll have it, which is more convenient than doing all this number stuff. All right, so here's the first thing you got to do is you got to figure out the average of the numbers. How do you figure out the average of a bunch? You got to figure out the middle. If you want to know how far they are from the middle, you got to find the middle first. So what is the middle? How do you find the middle of four numbers? Or what you can do? One at a time. I'm just kidding. You know, add them and divide. There we go. Add them up. What's that? 24, right? Divided by 4 is 6. So the average is 6, right? Then you subtract the average from each of them. Get the difference. That's -6, 0, and +6. All right. That's the difference, or it could also be called the deviation. Right? The social deviant, their behavior is different than normal. This is the deviation. We good so far? Making sense what I'm doing. So I just found the middle of the data set, the average, just to add them up, divide by 4 numbers, average is 6. So I subtract the average. Why? Because I'm finding out how far each of these numbers are from the middle. Trying to get their spread, right? So this number is back 6, 0 is back 6 from the middle, because the middle is 6. The 2 6s are right on the middle, so there's 0 from the middle. The positive 12 is +6 from the middle. Okay, now so those are the deviations. Those are how far they are from the middle. Now what do we want? We want the standard deviation, which means the average distance from the middle. So, but the problem is, you know how to find the average of things, right? You add them up and divide by. But if I add up those deviations right now, if I was to say, I'll find the average of these deviations, that'll be the standard deviation. If I was to average these, I'd have to add them up and divide by 4. But if I added them up, what am I going to get? 0. Every time. Because we're doing positive and negative from the middle. So if since we've got the middle, there's going to be the same amount above the middle as below the middle. That's why it's the middle. So we can't add those up, and it'll just be 0 every time. So we do kind of a funny way. We get rid of the minus sign, because that's canceling the plus signs. Here's what we do. We do the difference. We do the difference squared. So we take -6 squared, 0 squared, 0 squared, and 6 squared. 36, 0, 0, and 36. Then we add those up, 72. 72. And then when we're all done, we got to get rid of that 2 power. So we take that 72 and we square root it on our calculator, and we divide by the number of numbers, 4. And that'll be it. Let me make sure. I always get confused on one little point. If we divide by n or n-1, there's like a weird little difference. Make sure I'm not misleading you. Is it n or n-1? Yeah, by n, right? That's it. Add them up, square root it, and divide by the n. So let me write up those. Well, those are all clear. Let me write a few more words here to be more helpful to you. So does everybody see what we did? We squared those numbers, get the total. total, take the square root, the standard deviation equals the square root of the total divided by n. Wait, no, is that right? And then we square root afterwards? Oh, yeah, sorry. I'm not being very clear. It's the square root of the total divided by n. So you divide by the n first. Maybe best if I just wrote words. Take the total, divide by n, then square root. How about that? Let's take the total divided by n, square root. So what do you get? So you get 72 divided by 4, which is 18, right? 72 divided by 4, 18, square root of 18. You guys got that in your calculators? 4.24? 4.243, yep, exactly as the answer is right there. There it is. So let me slow down and answer your questions. Everybody see what we did there? We found the standard deviation of the number 0, 6, 6, 12. How did we do it? We found the average, add them up, divide by 4, 6. Subtract the average from each of them. Get those numbers. Because negatives are going to cancel positives, we just square them all. That's what gets rid of the negatives, right? When you square a negative, it becomes positive. So I square them all, add those up, 72, divide by 4. Why? Because I'm trying to average them. So you add up those 4 numbers and divide by 4. But then when you get that 18, you have to square root it because you're undoing the second power thing we did to get rid of the minus signs. So you square root it, and there it is. What is that 4.243 number? What is that? That's the average distance from the middle among those numbers. In other words, how far is 0 from the middle of these numbers? He's back 6. The two 6s are right on the middle, so there's 0 from the middle. The 12 is 6 above the middle. So some numbers are 6 away from the middle, some numbers are 0 away from the middle. On average, they are 4.243 away from the middle. Does that make sense? That's how far numbers are away from the middle on average. Some are more than that away from the middle, some are less than that away from the middle. On average, the numbers in this data set are 4.243 away from the middle. That's the average deviation. That's the average distance from the middle in this data set. That's the average spread. Does that make sense what standard deviation is? Questions I can answer on that? We'll try part C, unless you have questions. Let's try part C. Let me go to a fresh screen here. So let's do part C. So what do? You make a table like I just did with the numbers, the 0, 12, 12, 24, and then you got to put the average. You got to find the average, subtract the average, do that whole thing. I'll wander around and see if I can help. And a couple of you have the T. Oh, yeah, that's a Casio. And you have the TI. Somebody else has the TI. TI. Yeah, how do you do it on the TI? You know? That's right. You go to a whole class on this or something. So the cal, you go to stats, I mean?
Stat. Well, you have to put it in your list first.
Yeah.
So stat edit. And you put it in the list. And you go to stat cal. 1 bar stats. And you press enter.
And where's your, oh, hit edit? I see. Yeah. So, you got it? You know how to put in the list and all that kind of stuff? Yeah. And you found standard deviation?
Yeah.
On there? Yeah. Because there's 2 of them. You got the right one.
Yeah, they give you 2, but.
Yeah. Is it the S or the sigma?
It's the sigma.
It's the sigma. Okay. Who else? Pablo, you got it. Yeah. Do you understand what we're saying on that? Yeah. Know what that is? You got the list and everything? Yeah. You know do that? Yeah. Great. Good. Yeah, those are more tricky. Those little. So a couple of you guys got that, huh? Yeah. Let's see. I can probably. You have the same one as this, Richard, right? Anybody else have this little TI 30X? You got the same one. Let me see. What you do? You do like data or something. Stat one variable. got it, all right, so you getting it figured out? So first thing for the TI 30X people, you gotta clear this, it's got like a memory, even if you took the calculator off, it's still got a memory. So what you gotta do is you gotta go out of the stat mode and back in. You know how to do that? Go into stat mode, okay, and one variable, you wanna stay on, remember, hit the data button, let's see if it's got anything. So it's got nothing, when you see that, it's got nothing in its database, that's right. So, I'll show you this now. So first thing is you gotta go, okay, so there you are. It's stat mode, yeah, it's in stat mode. Hit X is a second, and X is stat, you know, you get the blue stuff above. So whenever, see how any key can do two things, it can do what's printed on the key, or it can do the blue what's on the key. Okay, it's second in the key. Yeah, let's see, so you just put it. Yeah. And say yes, and then stay there under yes. So you just exit this, see how the stat is not, now hit stat again. To get stat, it goes blue. So you're going to hit second. Okay. Yeah, and one variable's great, and enter your underline and one variable. Just what I mean. So as you move this across, it goes to other things. So you're already under the right thing, so hit enter right there. So it's ready to go. See the stat is right down there. Okay, now hit data, ready to enter data, and say, what's the first number you want? So go ahead and do the 0. Just hit 0, and hit enter. And it's saying, and then, then do that down there, and roll it down. It's saying frequency, like how many zeros do you want? We'll just leave it at 1. Just roll down. Now there's your second number. Second number is a 6. Let's do the last part. 6. And just roll down. You actually underneath it. And you can do 2 of those if you want, or you can just roll down and do a separate one. And just 6 again. And roll down. And then roll down one more time. What number is 12, right? And that's it. So it's got them all. Now, Richard, you figured out? Do you hit? How do you get your answers then? Right, I got all that. Once they're in there, how do you get your answers?
I'm not sure.
Oh, okay. I think it's in the step. Yeah, you do. Okay. Should just do that. Then turn it off and get it back on. So if they're in there, you don't have to re-enter them. It's got it. So at this point, like you can even see the data. It's got. Right, there's that first one. They're all in there. At this point, just hit second stat. And it's saying, okay, do you want the one variable information? Answer yes. I saw them in there. Oh, maybe just hit stat variable. Yeah, there it is. Okay. It's under stat. You just hit stat variable. It'll have all the answers with it. Right? There's and the number. There's the standard deviation. Just move that thing across. Yeah. Back on. Okay, just hit stat variable. Oh. And now as you move across it, it's underlining and it's saying there's the number of the tool. What's your numbers? Yeah. Oh, we didn't put in that fourth number. The fourth number, whatever it did for the 12. Well, we got to hit enter. We didn't hit enter. We should have to get this. Okay, my mistake. Anyway, yeah, hit stat variable. It's got them all. Now it's saying number of numbers. That's how I knew we were missing one. It was saying 3 a minute ago. Which means it only had 3 numbers in its data bank instead of all 4. So now it's got, so move the arrow across. X bar means the average. That's the word. And here's what we really want. Wait, this one knows the next one. There it is. There's that answer. 4.24. There's the standard deviation. So it's always this funny looking one. It's not the S. You might think it's S. It's a long story. It's the one after this. Yeah. Did you figure that out, Richard? There it is. That variable and all that. William, you got that with the TI? Yeah, so to do this on the TI, you can just hit, first thing you go into stat mode, hit, stat mode, oh, you just hit stats, a second stat. Hit enter for one variable. See the stat things lighted up now. Now hit data. You can type in your numbers here. Let's go back to the last problem again, 0, 6, 6, 12. So put 0, hit 0 and enter. Yeah, and now the down arrow, it say your first number is 0. It says frequency, like how many zeros do you want? Just one. So you don't need the indicator, you just move down. It automatically defaults. What's your second number? 6. Yeah, you can put 2 there. And the 12. And you gotta hit enter or down. And you just want to, it's automatically 1. So if you don't have to leave it, it's 1. That's good. We're good. Now your answers are under just to get to the stat rating. And at the end, that's the number of numbers. Move your arrow across to the one line X, but there's the average of those numbers. S is not going to go one more sigma. There's that 4.243. Now, if you want to do the next problem, you have to do more than clear, because if you go back into data right now, it's got the old numbers. So the only way you get rid of it is you exit stat. Remember, to get the stuff above it, you get the second first. Yeah, and exit. Say yes. Now erase it. Now go back into stat mode. And you above the key, you get the second. And there you can enter, and now you can enter new data, and you can it's cleared away. You can get a second problem. You guys get that? Calculators? Did you get it with the Casio? You figured out how to do it? Can you do it the shortcut way? You're okay with that? Because I'm sure there's Casios are always tricky for me, but I'm sure there's a way. What's that? Oh, your son knows how to do it? Okay. Oh, good. He knows how to do it with you? Yeah, good, okay. Yeah, I'm looking at it, there's a lot of buttons. Yeah, these are good calculators. These are cheaper than the TIs, and they're just as good. Wow, he's a sharp boy. He helps you how to, yeah. He's an engineer, you see him say. I'm sure he'll be able to help you, no problem at all. Good, you guys, oh, yeah, the TI. Yeah, TI is real easy. It's kind of mine. You just got to go into this list mode. Where is that? Oh, hit stat. Hit the stat key, and then edit. You want to edit? Yeah, and then you just enter the numbers down. So, oh no, just L1. So just go 0, 6, 6, 12. Just go 0, enter. And those are already getting it. What, it was 0. Oh, you're doing the new one. Okay, 24. That sounds good. Good. Okay, and now, put that second quick. There, yeah. And then go back into step mode again. And you can go over to calculate. Okay, one variable, that's it. And list L1, that means it's going to do those ones that were in L1 list. Hit in. Frequency list, I don't know about that. Just hit enter, so that's okay. Yeah, this was the thing, 8.48. Was that the answer, 8.48? Yeah, that's it. It'll look for you that quick. So just always put them in that L1 column. And it'll just crank them up for you automatically. You guys get, you get the same one? Did you hear all the instructions, data, all that? You're good. Casio, did you guys get that? You guys have the Casio? This kind of Casio? You got that, right? Did you get that, Snow? You guys have this Casio thing, this, what's it called? The National Display. My favorite calculator in the world. I got 3 of these. These are beautiful. These things. See, that's social media behavior right there. You call calculate beautiful, huh? Give me an example. All right, let's see. Let's see. How do you do it? Maybe it's not beautiful anymore. Stat. Oh, you see a stat button. There's got to be one. Buttons. Stat. There's a remove. Stat. There it is. It's hiding. Hit 3, 1 variable. I'll explain if it all works out. Let's see. So tables. Let's say 0, 6, 6, 12. Let's put it in that. So, move it forward. Okay. To stat mode. Mode. Stat. One variable. So it's again 0, 6, 6, 12. We can stat mode in. So how do I get this can try fiddling with it, I don't wanna waste everybody's time, I can try to look at it later. Yeah, I'm gonna have to move on, so I should, you figured out on yours?
Yeah, I got it.
You got it?
Yeah.
I mean, did you get it with the shortcut way, with the data button and all that?
Yeah.
Super easy, oh, good, it's in the instructions, huh? Okay, yeah, so grab me during the practice time if you want more help with that, I just don't wanna use up any more time. I'll grab the Casio Natural Display and try to figure it out during when you guys are taking the practice exam. All right, so there's the shortcut way, which majority of you have, that's great. Just hit the buttons, boom, there's your answer. I'll do it by hand here. What's the 48 divided by 4 is 12? So subtract 12, subtract 12, subtract 12, subtract 12. The difference is negative 12, 0, 0, 12, right? And then the difference squared is 144, 0, 0, 144. Add them up, 288. So take, and then what do? You take the 288, divide by 4, and square root the whole thing. So that'd be the square root of 472, which is that 8 point something number, right? Oh, where am I? Second. It's 8.485. Oh yeah, it's right there. Da-da-da. There it is. Good? Everybody okay with that? Cranking standard deviation on that? We good? All right. Now that you know what standard deviation is, look at part A. What's the standard deviation of that set? How much deviation is there? How much difference? None. That's why the standard deviation is 0 on part A, right? Those numbers are all the same number. There's no deviation at all. Like a society where everybody acts exactly the same. There's no deviation at all. No variety, right? The standard deviation is 0 for that data set, right? So remember, so there's two things you got to be able to do. You got to be able to crank out the numbers, which we just went over, and then you got to have a feel, because next are coming questions that really ask you, do you really understand what this is? That's really more important. Real life, you go out there in the world, nobody's going to say, can you calculate the standard deviation of that? Computers do that, right? But you might read a study, very, very possible, any professional job. Read a study, even as a consumer. Read a study, and they go, da-da-da was studied, this was the average, this was the standard deviation. To know what that means, to have a feel, real life, what does that even mean? That means the spread of the data, the average distance from the middle. So that means something about how spread out that data is. All right, let me show you the point. Okay, so number 6 here. So they want us to start with the data set 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you could do it by hand or by K. You guys have your calculator? Go ahead. So the numbers are, so that's where it's nice. When you have a lot of numbers, it's nice just to have your calculator do it. So the numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The average, I'm not sure. What is the average? 9. So it's 45. Don't they have to be 45? Divided by 10. Isn't 4.5 the average? I think. 24, 39, 45. Yeah. 4.5. So subtract. So this is tedious. This is why it's best just to have your calculator. Be able to do it with the buttons. This gets pretty tedious. All right, the difference is minus 4.5, minus 3.5, minus 2.5, minus 1.5, minus 0.5, positive 0.5, 1.5, 2.5, 3.5, 4.5, and then the difference squared. So I don't know what that is. 20.25, 3.5 squared, 12.25. 2.5 squared. 6.25. 1.5 squared. 2.25. 0.5 squared. 0.25. 0.25. 2.25. 6.25, 12.25, 20.25, add all those up. That's kind of a pain. This is 20.25 plus 82.5. So then you take the 82.5, you divide by 10 numbers, and you square root it. So 82.5 divided by 10, second square root of that is 2.872. Right. All right. Is that good? You guys had it 3 minutes ago with your calculators, right? Flip it out real quick with your calculators. 2.8, everybody see what I did there? So that's where it gets tedious, why you want to have the shortcut way with the calculator. So again, I'll get that for you. If you didn't get it, I'll get it for you while you take the proc exam. Show you how to do it. All right, so anyway, here's the moral of this question. The answer to part B and part C is going to be exactly the same. Do you see that? Why? Look at the data set. So they're trying to make a point. They're really trying to see, do you get it? Do you get what a standard deviation really is? So if you take the numbers 0 through 9, you take the numbers 0 through 9, and you add 1 to all of them, right? They'll become the numbers 1 through 10, right? If you just take those same numbers. That'd be like if the teacher gave a quiz, okay, and the scores the class got were 0 through 9, and at the last, and the teacher calculated the average deviation, the standard deviation, how spread they were. And then right before he or she passed back the quiz, got in a good mood and said, you know what, I'm just going to add 1 to everybody's score. So they just added 1 to everybody's score. So the 0 to 9 went up to 1 to 10. Is that going to change how spread they are? Not at all. They're just as spread as they were before, they're just 1 higher. They're all just 1 higher in number, but their spread from each other hasn't changed at all. Get the idea? So if you know that, you don't do part B. You just go, that's the same data set. They just added 1. I mean, you could do the whole thing, but it would come out to be the same answer. The same spread. And then part C, it's the same thing again. The teacher was in a really good mood, and he or she just added 9, right? Just add 9 to every one of those numbers, and you get these numbers. It's the same numbers with just 9 added. So again, now they took those numbers, just moved them way up, but they're still spread the same. It's the same standard deviation. That makes sense? That's what they're testing. Do you get it? Do you get what standard deviation is? It's spread. So if the numbers are all, what numbers, how far is 9 from 10? 1 away. 11, 1 away, 1 away, 1 away. It's always going up by 1 every time, just like the original data set. Goes up by 1, goes up by 1, goes up by 1. See how they're spread exactly the same. So it doesn't matter if they're 109, 110, 111, 112. Whatever. It's the spread that you're measuring when you do standard deviation. Does that make sense on that? Question, Joe?
So on these types of questions, that would be true for each of them? Like it would be the same answer?
Yeah, once you've done one of them, the other 2 are the same answer. Yeah, but you still have to do one of them.
Yeah.
You're right. I see your point. Good point. Yeah, you still have to do one of them. But once you've done one of them, the other 2 answers are going to be the same. So like on a quiz, probably what they would ask on the test, there's something like this. They might give you the answer to one of them and say, now what's going to be the standard deviation for this other one? And you go, oh, well, that's the same. Good? All right. Let's try one other kind of average. So we have 3 kinds of average, right? We have just normal average, where you just add them up and divide. We have, remember what the other kind of average is called? Mean? No, median. That first one is called the mean. The normal average is called the mean. Median is the second kind. Median's the one in the middle. Remember, you order them and take the one in the middle. Remember, it's the middle number. Middle number. And they use that. Why do they have another kind of average? Why don't we just have the one? Just add them up and divide. Why do we need another average? Anybody remember? Remember David Robinson, that data set? Super high number. So when you have data sets like houses and incomes, where you have some super high numbers and some super low.
The outliers.
Yeah, the outliers, that when you add them up, you get a middle that's not really the feel of the middle. The big numbers throw it way off, and it doesn't do a good job at giving you a feel for the middle anymore. So that's why median in those kind of data sets is a better middle, because it just puts them in order. It doesn't care if that top number's 1,000 or 10 billion, whatever. It's not adding them up. It's just grabbing the one in the middle. So super high numbers don't affect it. So anyway, so we have a third kind of average called mode. And that means the one, these are three kind of averages, the one that occurs the most frequently. If I said, what's the average shoe size for men? I don't know, it's 9, 8, whatever. 10, 8, 9, 10, whatever. How do they figure that out? Like in a shoe store. If you came in and talked to the shoe store salesman person and said, what's the average shoe size? Would they have added them all up and divided? No. They would just tell you the one they sell the most. They'd say the most commonly sold one is a 9 or an 8 or whatever, right? They wouldn't add things up. That'd be a crazy way to do average. You go 8.213, right? That's not what we mean when we talk about the average and the same, right? So we mean the one that occurs the most. You know where this is commonly seen as a joke? People say, what's the average number of kids per family in America? They always say 2.3, you know, and it's just funny. How can you have 0.3 of a child, right? So the point in that whole thing is that's the wrong kind of average. That's the point. They mean, what do American families most frequently have? 2 kids? Probably. Maybe 3. 1, I don't know, probably 2. Right? So that's the third kind of average. In some data sets, that's a better way to do average. You just mean the one that occurs the most. Right? So in this data set, there's actually 3 that tie. 4, 6, and 7 all occur 5 times. See how the frequency? They're the highest. Biggest bar, biggest bar, biggest bar. They occur the most frequently. So if there's more than one, you just list them all. Sometimes there's like a tie. It's kind of weird. But they're all tied for the most frequent. That's all they want on that. What are the modes? What are the ones that occurred the most frequently? 4, 6, and 7. Blah, 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 blah. Find the mode. Now, I mean, I don't need all that information. Find the mode. What is mode? One that occurs the most. Which color's the most? The purple, which is the Asian. Asian, done. Next question. Don't need all those words. All right, Mike's average on the first 2 exams in econ is 87. What must he earn on the next to raise the overall score? So if Mike has got an average on 2 exams of 87, what does he need on his third? Third to average 90. He wants to get an A. He wants to have an overall average of 90. He's got, on the first 2 exams, average 87. What does he got to get on the third to average 90? Well, I got the answer already up there. How do I figure that out? How do you average things? Add them and divide, right? So in the end, we want to average all 3 tests, but we don't know the third test. So what you do is you just pretend the first one's 87 and the second one's 87. I don't know what they actually are, but their average is 87, so you can just pretend they're both 87. Same result. Just pretend the first 2 are 87 right on the money. One might have been a little higher than 87, the other a little lower. I don't know, but I know they averaged 87, so just call them both 87. The third one, I don't know what it is, so call it X. And you add them all up and divide by 3 to get an average. What do you want the average to equal? 90. What's an A? There's my little formula, solve for X. Everybody see how I came up with that? Right? 3 exams. The first 2 are 87 because the average of the first 2 is 87. So 87, 87, and I don't know. call it x. That's what we're trying to find, the third exam, what do we need? So that you add them up and divide by 3, your average will be 90. Right, so we got to figure out what does that x have to be? What does that third exam have to be to make an average of 90? So how do we solve that little equation for x? You who have successfully made it through algebra, tell me. How do we solve that little equation for x? Times by 3. Or you could, some people find it easier to put this over 1, just cross multiply. Times by 3 is the same thing. Makes sense? So 87 plus 87 plus x all times 1 is 3 times 90. Seen that kind of thing before, cross multiply? Right? Or just multiply by 3, same thing. And so that 1 doesn't do anything. What's 87 was 174, I think, plus x. I think. 174 plus x is 270. Yeah, 174 plus x is 270. Subtract the 174, and you'll get the 96 that Mike needs on his third test. Is that good? Let's call the third one x. Everybody good with that? So just call the third one x, add the 3, divide by 3 equals 90, cross multiply, solve for x. You know, you can picture it, I think. Let me just go up here real quick. I don't want to use up any more time. Just real quick. You can picture, I think of averaging as leveling. So if you think, we got these exams, one's at 87, another's at 87. How high does this one need to be? Well, that was dramatic, not quite that high. But how high does this one need to be to make them average, whoops, not there, to make all 3 of them come out to average 90, right? You want all 3 to average 90. Does that make sense? Can you picture what I'm saying here? Right? So this third one, this third exam has to be above the 90 level so that it has some extra that can fill in these guys and bring them all up. It's like leveling a sand pile or something, right? Picture that I'm at the beach, right? And I got a big sand pile. I'm going to level this to make them all level at 90, average at 90. So how much extra do I need up here above the 90 level to fill this in and bring them up to 90? How much does this guy, 87, need to come up to 90? 3. And this guy needs 3. So you need 6 extra up there, don't you? Above 90. So you need to be at 96. We don't need no x and all that stuff. Just picture the sand. You got to have 6 above the 90 to fill the other 2 up, huh?
Will that work all the time?
Yeah, for averaging. Averaging is leveling the sand. Yeah. All right, well, that's enough with all that talk. Let's, that was 50 minutes. That is